So now I'm going to explain you how to set up the electronics for the UC2 system. So we have these ESP microcontrollers. They come in the form factor of an Arduino board, but the essential computational module here, the Espressif ESP32, is different. So it has Bluetooth, Wi-Fi, a dual core, and is in general also much more powerful than the Arduino is. It has lots of more RAM, so you can run web servers and all kinds of fun things. And the most important thing, of course, is you can control it with your PS4 or PS3 controller. In addition to that, we have the Cnc Shield that can connect different stepper motors, and we can also use several pins for example, the LED matrix and LEDs and lasers. Everything is driven by the power supply. In this case, it's a 12-volt power supply with a German connector, but it can also be used in America, of course. And in order to make it work, we have to do a little modification to the board. So there's like this little resistor, and we have to get rid of the resistor because otherwise it won't work. So brute force method, just speed it off, apply some force, and then we are good to go. There we go. So what we can do, it's not necessary, but we can add jumpers to the bridges here in order to allow microstepping. So depending where you place them, you have 2, 4, 8, or 16 fold reduction by means of microstepping. That's beneficial for if you want to do precise Z-stepping. I don't have them here right now, so you have to do that on your own. And then the next step is essentially just adding it to the board, make sure that all the pins fit into the dedicated holes, and that's it for now. If you want to have steppers, make sure you connect those. There are labels for A, B, etc. That's the output. Make sure those belong to the right hand side, so the motor connects to the right hand side here. Just place them here at the little cooling block, and then you're ready to go, almost. So you can drive the ESPs through the USB. So you have the ordinary USB micro, which just connects here. So we'll flash the firmware in a second. But this does not deliver power here. Most of the 12 volts power supplies have this plug, so this can go in here, and this also supplies the ESP32 with voltage. But unfortunately, there's no connection between that board and the board here. So we have to have one more wire, I'm just soldering it right now, which goes from this pin here to the power pin here. I'll do that in a second. So essentially, I just soldered one wire here. This is the V-in, which is the 12 volts from here, and we just plug it in here and then just screw it so that it won't get loose. With this, we're all set for one motor. We can also add a second one. Also make sure there's a little screw here that controls the motor current, depending on what's the motor you're using. For example, a NEMA 8 or 11 or 17, it varies. So you can, in principle, drive any motor at any current, but at one point it gets very hot and it eventually burns. Yeah, so this is the one we are using right now, and we are going to flash the firmware now. The UC2 LED array also connects to the same board. So this is just an Adafruit NeoPixel LED array with like the WS2812 LED. It has 3 wires, which is ground, digital in, and 5 volts. We labeled it, it's almost invisible now, but so let's just sneak in. So this is the one for ground. So we hook it up to the ground here, which is right here. Then we have the 5 volts, which is obviously going to 5 volts. And then we have the data pin, which goes to the pin number 4, which is actually on this board, the hold. So right here. So if we now reset, we expect it to get blue. That's just because it's programmed the way that all LEDs go to blue. And we can manipulate that, for example, by changing the state of the LED array by means of, for example, doing oblique illumination or upright illumination, etc. And we do that now by changing get or sending yet another command, for example, the bottom command, where we set all LEDs, the bottom half, to 139, like that. So now it's getting white. We can also set that to only red, so that we see it like that, or for example, very dim, so that we set it to a very low value. That's all also implemented in ImSwitch. So it's relatively straightforward to add arbitrarily complicated electronics all through a modular framework. So to see that this is actually also working in reality, we have connected the Z stage that we just built together earlier. And so what you should observe when you restart the ESP32, so unfortunately this button is not working. It is. So it will just do a quick functionality test by quickly moving the motor in one and the other direction. And so when we now want to move, let's say 1,000 steps, we can just copy paste this line here. This motor is now connected to the X position. And so we place 4,000 steps. This one does not have any micro stepping, so this will be several rotation now. And so I just use 1,000 steps with a speed of 1,000 per minute. And that means the stage is moving up or down. So if I do it again, nothing will happen, because the absolute here is still set to 1, so it will just go absolute position. If I turn this to 0, that means the stage will move relative position, and I can just go in the other direction again, and again, and again. And if you want to go slow, you can also go down again. And you already hear that there is a relatively loud sound. This goes away if you do micro stepping, and for this you just add the jumpers here. So one, for example, is mounted right here, and you can add more.